Good morning, everybody. This is a presentation for our research. My name is AKM ASHIQUZZAMAN, and today I'm going to talk about our research that is a load balancing scheme for gaming server applying reinforcement learning in wireless network. So, in this project, we used a load balancing scheme that implements reinforcement learning in the wireless network to bring in a special kind of project that uses the reinforcement learning ability to give a load balancing system for gaming server. So my name is AKM ASHIQUZZAMAN and I am from Chonnam National University, and my other researchers are Professor Hoi Young Kim and Kim Jin Soo. So I, AKM ASHIQUZZAMAN, will talk about this project in briefly for this research. So now let's go to what are the content. As you can see, at first we're going to talk about the introduction and the basicalities of this project, which will be covered in the introduction section, and there will be a load balancing agent applying reinforcement learning, and we will talk about the simulation, the performance analysis, and finally we will talk about what we have done in this project and the conclusion of this project. This presentation is separated in 4 sections, and I'm going to talk about each section briefly in the later part of this presentation. Now, as in the load balancing agent, we're going to talk a little about what is load balancing and what is reinforcement learning and how we have done it in the simulation, and we have analyzed our performance, which is far better than the previous section. And finally, we have talked about the conclusion of this project. Now, let's go to the first part of this project. What are these things that we have talked about? So in the introduction part, I'm going to talk about what is this project is about. Now, a large amount of event data is gathered in a gaming server. So first, I'm going to talk about what is a gaming server. When there is an internet-based multiplayer gaming system, there should be a server that handles all the data input, and it merges and gives the output in a real time so that the gamer can interact between each other via this server and play a game in real time. So this kind of server is called gaming servers, and this kind of server is very, very famous in our modern day world, especially because there are a lot of multiplayer systems. Especially in Korea, if you know, the League of Legends, or LOL, is a multiplayer internet-based game, and it is very, very famous and it takes a lot of gaming server to manage this kind of massive online playing game. So for this kind of gaming, we need a gaming server. So what is the difference between the gaming server and the general web-based server, such as like Facebook, YouTube, or any kind of website? So gaming server had to be very, very fast processing, and it has a lot of ability to do communication in a short gap, as in the network section we call it, with no lag time and very little ping. So when the gaming server has a large amount of data, we need some kind of load balancing scheme. So the data that generated from each users to the server, we need to balance this in several gaming servers. So usually in the gaming server system, it is not only one but several kind of servers together. So what we do is that we make load balancing scheme in multiple servers that act as together in one server. So this load balancing scheme is usually done by a heuristic or a machine learning based approach. So both of them are AI based system, as you have known, but in our performance, we have done a new kind of reinforcement learning system. So that gives several advantages than the other systems that we have done in our research system, that is superior to the other systems that are commonly used in nowadays. So as you can see from this slide, I'm going to talk a little about what the slide says. So a large amount of event data is generated in this gaming server. So load balancing scheme is crucial for this efficient gaming server. So we have proposed an agent that applied a reinforcement learning based method, and it shows several key functions of our schemes, and it compared the performance of our scheme to a previous research, that is the PROGR, that is a system that has previously used in the multiple load balancing scheme. Now, before talking about the load balancing agent, we have to talk a little bit about the reinforcement learning. What is a reinforcement learning? So as you have known in the previous system, previously, the learning can be two types. There is a passive learning and then active learning. So in the active learning, the learner, which you can also say agent, can interact with its learning environment or his surroundings, and based on his action, he gets some kind of reward, which can be a positive or a negative, and it adjusts his outcome to get the maximum reward or minimize his error to get the maximum kind of reward. This is called reinforcement learning. Now, in the reinforcement learning, we can separate the main components into two parts. One is the agent and one is the environment. So agent takes some kind of action, that is A. For this action, it gets to a new state and it gets a new reward. So that reward is pitched to the agent. If the reward is positive, the agent takes that kind of action more. If the reward is negative, it doesn't take that action and it goes to a new action. And most of these get by one state to another. So basically, the agent improves its behavior to maximize a reward function. Now, what is this reward function? It can be any kind of mathematical function that can reveal how you can measure the goal or achievedness in a single term. So in this agent system, it has to improve its behavior to maximize the reward function, which you have to define for our proposed system. So our proposed system, we work with the load balancing scheme. So in the load balancing scheme, you have to balance the load between the servers so that our load will be not too much in one server and proper in many servers, and not any server is sitting idle. So this should be appropriate behavior for an agent. And how it will learn? It will learn by retiling and learning from its environment. So let's go back to the first thing that we have talked about. In the load balancing agent that applies the reinforcement learning, it has to take some kind of, how can I explain this is possibly? So it takes reward function and it has some kind of system that uses this kind of function, as you can see from the slide. And there is this load balancing agent that applied the reinforcement learning, which is CIJ is that log-based SINR. As you can see, this is the service rate and the base node of user and the base station and what is the service rate. And we calculate the long-term service rate, which is actually the one of the reward function of our agent. So these two functions that here is actually compared the reward function and it gives the agent how to behave. So let's go back to the previous slide we have talked about. So this is the load balancing scheme that is applied in the reinforcement learning, and this is the reward for each station that is allocated properly, and there is an allocation priority. So as I have said before, in the reinforcement learning system, your allocation has to be a priority to manage all the load balancing system. So if you don't allocate this load balancing system in a priority basis, your whole system will be failed because the online system focused on too much about how to get the load balanced and small left time. So this is the function for each reward based on the station, and the priority of this allocation. Now, in this part, we're going to talk about our simulation and performance analysis. So, as you have known, the gaming server needs to, and our process needs to be simulated rather than apply it in the real scenario first, because making a real-time playground or a seed generator or some kind of real-time simulation is very difficult and expensive in server-based application. So we have to make some kind of simulation and we have to analyze the performance, and if it is viable, in the next step we usually make the real thing. So I'm going to talk a little about what is the simulation and how we have analyzed our performance. Now the ML agent that we made in this are from the library that is called Unity 3D. So Unity 3D is an engine that can create many kind of simulation or games. So we made these ML agents out of this Unity 3D system. And this was processed by repeated cycle of sending variables by the TensorFlow library, which is a Python-based library, machine learning library by Google. We use this TensorFlow and Unity 3D together to make this system. And the result, which is done for the reinforcement learning agent to learn, is called a proximal policy optimization algorithm. So usually you can see there is a shortened abbreviation for this algorithm. It's called PPO. And there is another advanced improved algorithm system. It's called the proximal policy optimization 2. So in the TensorFlow, even though we are talking about proximal policy optimization PPO algorithm, it can be PPO2, it can be A3C, another kind of algorithm for reinforcement learning. And we can actually take any kind of this algorithm and we can learn our agent by this. So in this scenario for our simulation, we first made the ML agent on a Unity 3D. We simulated it. We send this result to the TensorFlow. It learned from this system, and then finally it gives that this policy to learn in the simulation as an action, and it achieves the optimized load balancing scheme by doing so. So in this part, we're going to talk about how we have made this system. So let's go back to the result. In this result, it shows the environment of the simulation, the result of the load balancing system, and the proposed scheme and the previous scheme system. Now, if you see the section A is the simulation environment, and this is how the system is proposed to balance the load. And this is our previous system that was done in the ProGRE GA, which is a genetic algorithm-based scheme. And this is how it has simulated and optimized the previous server. But ours are very fast, and it is simulated by the reinforcement learning system, and it is far better in performance than the previous system. So as if you can see, this system is made up by 15 by 15 place grid world, and it has 225 cells with 8 servers. So it takes the user load by occurring 250 user AI. Then the agent select a cell that hasn't been selected before, it gets a plus reward, and for if it is selected properly, and gets a minus 0.1 reward as a negative reward. So negative reward is actually being discouraged to do this kind of action, and positive reward is encouraged to do this kind of action. After some kind of cycle running through this whole system, it gives a proper result and optimized server system. Now, let's talk about the simulation and the performance analysis. Our proposed scheme shows there is no rapid change in the occurrence rate in the average result. So the fragmented cell or the average fragmented cell, it is good than the proposed previous system. So in short, the experiment result of this model has learned through the screen shows that there is a 70% increase in the performance compared to the previous research, which is the PROGREGA algorithm. Now, in conclusion, let's talk about what we have done. We have done 100 experiments in the load balancing under various conditions, and more fragmented sets are not allowed to server for load balancing, and thus it gives performance that is very good comparing to the other system. So in conclusion, we have proposed an agent that applies a reinforcement learning method to distribute static loads for gaming server. Then we compared this performance to the previous scheme and the widely used other scheme, and we have a 75% increase in productivity compared to the other method. So in conclusion, our project and our work is definitely far better in the based on the general consensus. So thank you all for listening. If you have any question about this paper, please send an email to the authors, which is me or any other authors. And thank you all for listening to our project and our research. If there any question and answer, please send the email. Thank you all for the listening.